எப்படி விட்டுருக்கோம் இதுவோ கழிக்கணும் இப்போ லாஸ்ட் மினிட் பண்ணி டேப் அடிச்சுட்டு உங்ககிட்ட கேட்கணும் அப்போ இன்னும் அந்த ஃபுட்டு நான் உங்ககிட்ட இல்லையா நீ என்ன பண்ணுறது கடைசி
சரி.
Check, check. Good morning, ladies and gentlemen, to this magnificently glorious day. It's my immense pleasure to welcome heads of the departments, faculties, students of first year PhD Tech, higher secondary students of PhD Public and Sarvajana School who've come to make this Founders Day a grand success. A community goes by a strong watchword. Ladies and gentlemen, that is action. No amount of planning is going to do wonders if it is not acted upon. And taking action inspires others to follow. With no doubt, we can say that the PhD community is a living example of it, because here we make any plan with life, zest, and power to change the future is immediately put into action. We have gathered here on the occasion of Founders Day, and to begin with, it's my immense pleasure to call upon Dr. P.R. Thaila, Professor and Head of Department Mechanical Engineering, to present the welcome address.
Thank you. A very good morning to all of you. It is with immense pleasure that I welcome all of you to the special address for students by our distinguished chief guest, Padma Shri Professor Dinesh Singh, currently Vice Chancellor at K.R. Mangalam University, Gurgaon. It is an honor and a matter of great pride to have amongst us today the very renowned chief guest, Professor Shri Dinesh Singh, former Vice Chancellor, Delhi University, and a Padma Shri awardee. As we all know, Padma Shri awardee is one of the highest civilian awards of the Government of India, awarded by the President of India. Professor Singh is currently the Chancellor at K.R. Mangalam University, Gurgaon. He is a globally recognized mathematician and a highly educated academician, and had held and also holding now also very coveted positions in many Indian and overseas universities. We are indeed fortunate to have him here, since in spite of his numerous commitments, he's been benevolent to devote his time to be with us today. And he will be enlightening us on the title From Indus Valley Civilization to Srinivasa Ramanujam, A History of Mathematics. On behalf of the management, the principal, faculty, staff, and students, I wholeheartedly welcome our chief guest. A very warm welcome to you, sir. I also wish to extend our sincere gratitude to him because he's been very busy this morning. He has already we already had a lecture by him, special address by him offered to the faculty of PhD institutions. It was really enlightening, and we were all enthralled the lecture. It is my pleasure to welcome the heads of departments, all deans and heads of departments, heads of institutions, faculty members, and student friends to this special occasion. We are all eager to listen to you, sir. And I once again extend a very warm welcome to every one of you. Thank you.
Thank you, ma'am. We have with us a distinguished academic leader and innovator, thinker, educator, and policymaker. It is an honor and privilege to have with us Padma Shri awardee Professor Dinesh Singh, a multifaceted personality and a man of several accolades, as the chief guest for the day. Professor is currently the Vice Chairman at Jammu and Kashmir Education Council. He has led Delhi University to great heights during his time as Vice Chancellor there. Established the Cluster Innovation Center at Delhi University that has launched extraordinary degree programs in humanities and in innovation with IT and mathematics. His current positions include, but not limited to, AICE Distinguished Chair Professor, Adjunct Professor, University of Houston, Chancellor, K.R. Mangalam University, Gurugram, Distinguished Professor, Shilluni University. He has several honorary doctorates, such as, but not limited to, from the University of Edinburgh, National University of Ireland, University of Houston, National Institute of Technology, Kurukshetra. He has occupied many coveted positions in several sectors, such as Member Scientific Advisory Committee, Union Cabinet, Government of India, President Ramanujan Mathematical Society, India's premier mathematical society, AMU Prize of the Indian Mathematical Society, Career Award of the University Grants Commission, and Ramasamy Iyer Award Lecture, Indian Mathematical Society. Professor Dinesh Singh's research is in the realm of harmonic analysis and operator theory. His research has been cited in numerous books, journals, and has been taught in courses. He has served on the jury of the Jnanpith Award, one of India's most prestigious literary awards. He has pioneered several new ideas in the realm of education and on the role of technology in education. With this, I deem it my utmost privilege to welcome Professor Dinesh Singh on stage to enlighten us on the topic From Indus Valley Civilization to Srinivasa Ramanujan, A History of Mathematics. The stage is yours, sir.
Thank you very much for your kind welcome address. Thank you for your introduction. I address all who are present here. I'm delighted to be here. I'm in a famous institution. I know its relevance in today's times and I know its historical value. And it gives me honor to speak from this platform. I'm also sorry that we are running a little behind schedule, but we'll try and make up for that. It is also important to stick to time schedules. And I presume, how much time would you give me, madam? 12? 30. Okay, so it's 12 o'clock now. Okay. 30 minutes. In 30 minutes, I have to compress India's history in mathematics. It took them thousands of years to make that mathematics, and we will do that in 30 minutes. I will try and do justice. I'm starting with the assumption that those who are present here are at least not afraid of or dislike mathematics. Is that safe to assume? There is no mathematics in my lecture of a technical kind. I want you to get some idea in these 30 minutes of what is India's contribution to the world of mathematics. How did India take advantage of that? And I'll do my best in this little time at my disposal. As the title suggests, it covers from the Indus Valley civilization till Srinivas Ramanujan's time, which is part of the early part of the 20th century. I am sure all of you have heard at least a little bit and known a little bit about the Indus Valley civilization. It's huge civilization spread across many parts of northwestern India, from the port of Gujarat known as, I forget the name of that port in Gujarat, very famous port. Anyway, from Gujarat all the way to Sindh, areas covered in Haryana, Rajasthan, Delhi and beyond. More than 1 million square kilometers. Huge civilization. Very sophisticated. It flourished thousands of years ago. In fact, its date is not perfectly known. There are all kinds of assumptions, but even the most conservative estimates say it was about 2,500 years before the time of Christ. You follow? So that's how long ago it was. Some people go much beyond that. Let's leave that aside. There are many mysteries, other mysteries, not just the date. That civilization had a language which used a certain script. How do we know that? Because lots of clay tablets have survived. Lots. On those tablets, we have images inscribed of the script. But we don't know what they say. It is one of the great mysteries. Some of the finest minds from history, archaeology, computer science have tried and are trying to tell us what the script says, but no one knows. There are all kinds of speculation, but no one has really been able to decipher the script. And if any of you ever wants to take up this challenge, you will become famous if you solve this problem. Even if you don't solve this problem, in the process of solving it, you will learn many important things and you may make other discoveries. It was a very sophisticated civilization. What is the first hallmark of that? It was a city civilization. There were no villages. This is so long ago. all city dwellers. Imagine, just imagine, 2,500 years before Christ, these were cities built with baked brick, clay brick, baked brick, throughout this entire million square kilometers. The bricks are in perfect shape. There is a certain proportion of the length, breadth, and height of the brick. Perfect. All through the civilization. There were other indications that you get even though you don't understand the script. Other kinds of indications. They had a system of weights. There is now enough evidence that they understood the decimal system by simply looking at what they have left us. They used a scale for measurement, which is now known as the Indus foot. It is a little bigger than our 12 inches. It's about 13.2 inches or something like that. Little bigger. I believe they were taller people in the north, and their foot must have been quite large. There's also an inch, the Indus inch, that unit of measurement, which is just a little larger than our inch. And they had, on the scale, they had 10 equal markings. Pretty evident that they were using decimal system. So 10 inches to a whole foot rule. You have 12 on your school foot rules. That is 10 inches, 10 markings in parallel. And that's indicative. They had a system of weights in which if you picked one as the unit weight, every other weight was a proportionate fraction or a multiple. So there were, and you could make any one of them the unit weight. The others would then fall into place. They were really sophisticated. That system of plumbing was highly advanced. Highly advanced. The Gujarat port, by the way, is Lothal. The name has come back to me. Lothal. If you ever get a chance, look up Lothal, Lothal, on the internet, and you will learn many things about Lothal. And these things we can glean from whatever little survives. But as I said, it remains a mystery. They were highly advanced. The buildings were all perfect shape. You know, when they measure the heights of the buildings, they conform in a uniform way to measurements right through the whole civilization. Today in India, it's very difficult to conform to standards. You know, bricks in one part of India may not be exactly like bricks in another part. And there isn't that much standardization even for our sockets and plugs. No, it's very hard to get a plug which will fit every socket. Very difficult. Now it's getting better in India. Up until a few years ago, you never knew. It was a matter of chance. You bring a plug from Delhi, may not fit in Chennai. You bring one from Chennai, may not fit in Delhi. But that was very standardized. So you can get an idea of how sophisticated they were. Other mystery about the civilization is that suddenly it seems to have died. Suddenly, this huge, vast civilization. It just seemed to have somehow stopped. The buildings survive. And for centuries, no one had known about that. Till in the early part of the 20th century, archaeological excavations happened first at Harappa, now in Pakistan, and then Mohenjo-daro. But we know that they were sophisticated, they understood mathematics, that they had an idea of the decimal system thousands of years ago. And when this goes, as I said, there are all kinds of speculations. Some people say there were major geographical upheavals, tectonic plates shifted, the rivers dried up, there was famine, maybe disease. No clear idea. Or maybe a war. But it just suddenly vanished. No one knows what happened. But when that system vanished, or around that time, another civilization was taking root in India. That was 2,500 years before the time of Christ. At least, again, all these dates are pretty hazy. But I just give you a rough ideas to let you know how ancient all this is. So from today, 4,000 years, 5,000 years ago. So what was that civilization? It's a so-called Vedic civilization. What do you mean by that? That is the time the Rig Ved and then the other Veds were composed in India, in the parts of upper northern India. And that civilization, the so-called Vedic civilization, For that, our records, our history is very clear. And it gives us deep insights into the profound mathematics that they discovered during the Vedic civilization. And I'll tell you a quick story. I presume all of you, or most of you, have heard of the theorem of Pythagoras. It's known as the theorem of Pythagoras. Is that how they teach you in school, as the theorem of Pythagoras? What most people don't know, or now at least for the last 30 years, I have been speaking all over the world about this fact of history. So now lots of people know this, but still not enough. That the theorem of Pythagoras was known in India hundreds of years before the time of Pythagoras. And in 800 BC, there is a text that survives till today called the Shulba Sutra of Bodhayan. In that, the theorem is clearly enunciated with a construction for the proof. And one of the best proofs that I know of the theorem of Pythagoras is enunciated in another text which comes before Jesus Christ. Bodhayan was 300 years before the time of Pythagoras. How did Bodhayan discover this? So in India, that is a lesson you must understand, because unfortunately when you are taught mathematics, you are not able to easily connect it to the needs and challenges of society. But the Indian tradition was not like that. How did the theorem of Pythagoras get discovered? What was the text? It was known as the Shulba Sutra of Bodhayan. Bodhayan is the mathematician author. What does Shulba Sutra mean? Shulba means a piece of cord or a string. Sutra is a formula or an aphorism. So these are mathematical discoveries connected with the use of a string. What does that mean? Even today, if you ever get a chance and you find some major construction happening in any part of Coimbatore, go and see, watch the mason, the bricklayer at work. When he's laying the bricks, he's using a piece of string with a dead weight. I'm sure some of you have seen it. He uses that to measure, to lay the bricks properly. For all his construction, he needs that. That is what is the title of the Shulba Sutra. Shulba Sutra, that same dead weight with a string and weight at the end for all constructions. What were they using it for? All architectural constructions. One of the major constructions of the Vedic civilization was the fire altar, the Yajna-Vedi. If you have looked, there are all kinds of Yajna-Vedis, but the most common that you will look at is a square and there's another square inside it. I haven't brought any images, that's my mistake. But just imagine, so there's a square and there's another square fitted inside that square. That's how Yajna-Vedi is. But there are all kinds of Yajna-Vedis for different purposes. All of them required sophisticated high-end geometry much before the Greeks understood how to do geometry. And Bodhayan Shulba Sutra mentions how to construct a particular Vedic Yajna-Vedi, and while doing that, he shows you how within that Vedi you can find a proof of the theorem of Pythagoras. State the theorem and prove it. Of course, we still call it the theorem of Pythagoras, but many books, even in the West, now call it the theorem of Bodhayan Pythagoras. Here's another quick story. Very few of you know that Pythagoras actually came to India. I have discovered so much proof now that he came to India. So much proof that there is no doubt. And not only did he come to India, he came to learn. And he was highly influenced. I have now enough proof. This is not the time to show you the proof. Historical proof, not someone who says this or that. No, hard facts of history. He got influenced by Jain philosophy, became a vegetarian. And in Jainism, you're supposed to be a complete vegetarian. You should not wear anything connected to leather. So he stopped wearing leather garments or leather sandals. And he used to eat his dinner before sunset. Jainism requires that. But he spent a lot of time, and therefore there is enough speculation, which is reasonable, that says that he must have learned the theorem over here. But that's not the only thing. There were many things happening hundreds of years before the time of Christ. Hundreds. I don't know if you have ever thought, is poetry connected to mathematics? Has anyone ever thought about it? I doubt it. A few hundred, 200 years before Jesus Christ, there was a prosodist, a person working in Sanskrit poetry named Pingal. Pingal was trying to create new meters using various permutations and combinations of existing sounds of meters. There are already existing very famous meters like the Gayatri meter, the Anushtup, etc., etc. So he was creating new meters for poetry. And he was using various permutation combinations. Take two long, short sounds, one short, choose 5 out of 7 long sounds, and then 3 out of 4 short, and make combinations, so on and so forth. In doing this in poetry, he discovered a mathematical device which you may have known of as Pascal's triangle. Pascal was a genius mathematician of the 18th century in Europe, 17th or 18th century in Europe. He discovered it at that time. It is known as Pascal's triangle. It is a very profound device. That triangle was actually discovered by Pingal 200 years before Jesus Christ, so 1800 years before Pascal, for reasons of poetry. And you know the numbers in that triangle. How many of you have heard of the binomial theorem? I'm sure many of you have heard of it. I'm not asking to test you, so don't be afraid. The numbers in the Pascal's triangle are nothing but coefficients of the binomial theorem. And if you have heard of the binomial theorem, then you must have heard that Newton discovered it. Actually, a man called Halyut in the 12th century in India, when he was reading Pingal's work from 200 BC, so he was reading a work that was 1400 years old, and he saw Pascal's triangle and he began to work on it. Pingal called it the Meru Prasthar, steps leading to the mountain top. If you ever look up Pascal's triangle on the net, you will see it is really like steps leading to the mountain top. He discovered the binomial theorem, Halyut, hundreds of years before Newton. So you see all these major discoveries of Europe were actually anticipated, not all, but most of them were anticipated in India. The Indian discovery story is amazing, and I'm not talking of chauvinism. I'm not talking about beating my chest. I'm giving you hard facts from history. In this short lecture, I can't produce all the evidence, otherwise there will be no time. But there is hard evidence from very distinguished thinkers, researchers, scientists. But let me also tell you something else. The decimal system was invented in India, and the numerals, those are known as, when you write 1, 2, 3, they just come from the Brahmi numerals of writing 1, 2, 3. 1 is written in Brahmi exactly as it is written now. 2 was 2 parallel bars. And over time, it evolved into a connection between the 2 parallel bars, so it became a 2 like that. 3 were 3 parallel bars, they just connected, it became 3. 4 was something like that, and they just added something, it became 4. Exactly. So all these numerals are not Arabic, they are Indian. There is hard archaeological evolution of, you can see how these numerals are starting from before the time of Christ and moving on. So what is the evidence? All kinds. I'll give you just one lovely story. Before the time of independence, when the British ruled India, there is a place near Peshawar, which is now in Pakistan, called Bakshali. In Bakshali, there was a man digging up the land. And while doing that, he came across a manuscript written on bark of the birch tree. You take a bark of a tree and you could write. This manuscript was written on the bark of a birch tree, and it is an ancient manuscript full of mathematics, profound mathematics. How old is it? Well, it is a commentary on an earlier mathematical work. What are the things in the Bakshali manuscript, as it is now called? That manuscript gives clear use of the decimal system. The manuscript itself, by conservative estimates, is somewhere just after Jesus Christ. But it is a commentary on a work that is before Jesus Christ. So you can see that the decimal system was in use, but it isn't just decimal system. And by the way, the greatest of mathematicians of history have said that one of the finest inventions of the human mind is the decimal system, a complete invention of India, coming from practical needs. Not someone sitting and doing something in theory. Indian geometry evolved for practical reasons like construction, and all this was done much before the Greeks did their geometry. But I just want to give you a glimpse now. Later you will have time to find things on your own, or maybe if I come again, I'll give you some references and then you can check them out. But just think that the Bakshali manuscript also deals with quadratic equations and how to solve them. Imagine those, when the Europeans were complete cave dwellers, they had no idea what is mathematics. The Bakshali manuscript deals not just with quadratic equations, it deals with negative numbers. It tells you how to add fractions, how to subtract fractions. It gives you other formulae. It is 60 odd pages now survive, all the others were destroyed, and they are not in India, they are in Oxford University. But if you go to the National Museum in Delhi, you will find a photo image of the pages of the Bakshali manuscript. You will also find it on the web. And you can see how they used to deal with fractions and negative fractions and so on and so forth. And the story continues. The Indian story of mathematical discovery continues. And I will just give you a few of the great highlights. So in the 5th century, there was a mathematician, astronomer by the name of Aryabhat. He made profound discoveries in maths and astronomy. Before his time, Indian astronomy had begun to become a little unpredictable. People were making mistakes with their calculations. Aryabhat recalibrated all of the mathematics needed for astronomy, redesigned it. He was one of the first people to write categorically that the earth is spherical in shape and that it revolves around its axis and goes around the sun. It is not the sun that goes around the earth. All this is mentioned in his fundamental work, Aryabhatiya. He also calculated the radius of the earth. He also did many other things. He was a genius of the highest order. And he used trigonometry. I'm sure many of you know what is trigonometry in school, and you do sine and cosine. What you don't know is that trigonometry was invented in India. At least from around the time of Christ, but I have now got evidence that it predates the time of Christ by hundreds of years. In India, they call the term sine as jya and cosine as koja. If at all you have come across these terms, I presume that those who study maths in school will know trigonometry a little bit. From India, this trigonometry went to the Arabs. The Arabs made a phonetical translation. They didn't translate it into Arabic words. So they called the jya, jab. And so koja became kojab. Sine and cosine became jab and kojab. From jya, koja. The Arab mathematics was then translated to Europe, and the Europeans made a literal translation. So jab in Arabic sounds like a pocket, and the word for that is sine, and that's why they called it sine, and so kojab became cosine. That is the origin of these terms. Nothing Latin about it. It just comes from India, and we invented trigonometry for the sake of astronomy. And not only that, the story goes on and on. The other famous name, just 200-300 years after Aryabhat, is Brahmagupta. Another genius, extraordinary man. I don't know if you've ever tried to add numbers, but if I ask you to add numbers from 1 to 100, you could do it by adding every number, or you could actually have a formula, a lovely formula. And with that formula, you can do that in half a second. But the problem becomes even more difficult if I ask you now to add the squares of numbers. So 1 square plus 2 square plus 3 square up to 100 square. It's very difficult. And why 100 square? You could take 1,000 square, a million square. Brahmagupta had invented a formula for that also with proof. And then for cubes also. He was an outstanding mathematician. He did many things. He knew how to solve very special, difficult equations of number theory. So these were sophisticated mathematicians. And you know, I don't have much time, so I'm going to just give you one more mathematician, 12th century Bhaskaracharya, the second. Probably the greatest of all of ancient Indian mathematicians. You've heard of Isaac Newton. You know that he invented gravity, he understood gravity, he used Newton's laws of motion, he understood planetary motion. He invented, to understand all this, a mathematical theory called the calculus, differential calculus. What most people don't know is that 500 years before Newton, the calculus was invented by Bhaskaracharya. For the same reasons that Newton used it. Study the motion of planets. But 500 years before the time of Newton, that was his contribution. And the calculus is considered one of the finest inventions of the human mind. And that has really been invented in India by Bhaskaracharya and others after him, but before Newton. Huge amount of calculus was discovered. Finally, great calculus was coming from Kerala. Amazing. All before Newton. So you can see how, and you know that those ideas of calculus were used in architecture in southern India. All the famous big temples made with rocks of southern India. The architectural ideas are based on the calculus. Western architecture only in the 20th century began to use mathematics with architecture. The Indians were doing it for hundreds of years before that. Unfortunately, now in India, architecture doesn't use maths. I don't know what has happened. And why do I tell you this story? And why do I wish to tell you the story of Ramanujan? Because you are young and the future of India. On your shoulders will rest the well-being of this nation, the well-being of our country, our society. And I want you to take pride, to have confidence that India has this glorious tradition of knowledge, particularly mathematics, and its applications to various things. Be confident, never be overconfident. Never do foolish things, but use this confidence. It's in your genes to use the mathematics for the well-being of society. Somewhere when we got colonized, our knowledge systems began to die and we lost our confidence. But then a miracle happened because the Indian mind and spirit can never be subdued. A genius was born not very far from you, where you and I are talking to each other. A genius by the name of Srinivas Ramanujan, born in a poor family. It was difficult for him to have proper food in his young days as a schoolboy. Very difficult for him. But at a very young age in school, he became inspired by mathematics and then he devoted himself fully to mathematics. And while still in school, he made enormous, profound discoveries in mathematics by himself. There was no one to tell him that the Europeans have already done this, so now you can do some more. Nothing. He had no idea what was happening in Europe. He just started creating mathematics that Europeans had taken 200-300 years to create, just sitting by himself in Kumbakonam, a small hamlet, not too far from here, in a poor family. And because he was a genius, they gave him a scholarship which he used to gain an entry for the 12th exam, which is known, I think, as a certificate, known also as intermediate from Madras University. But he neglected all other subjects, so he failed the English exam. Unfortunately, India in many ways is now, hasn't changed today, it was like that 100 years ago. Because he failed English, they stopped his scholarship and threw him out of the university. But you know, Ramanujan was Ramanujan. It didn't matter to him. Even if he had nothing to eat, he would not give up mathematics. His mother had him married off thinking that now maybe he'll become responsible and take a job. Sure enough, he took a job as a clerk in Chennai, Madras Port Trust. But the boss there was a good man, Englishman. He said, you can do mathematics, I'm not going to ask you to do clerical work. So Ramanujan would write mathematics on the other side of all the files that were stored in the office, which were not of use. One side was blank always, he would do the mathematics there. And he began to make profound discoveries. Profound. And Indians couldn't understand what he was doing, but they knew there is something great about him. So there were some people who helped him, even though he did not have enough to eat. He was barely able to meet his ends, but he didn't worry, he wanted to do maths. Finally, he managed to reach, after many attempts with many mathematicians, he managed to reach a famous English mathematician by the name of G.H. Hardy. Hardy is my mathematical grandfather, in other words, my guru's guru. And I know the tradition in which Hardy worked. Outstanding mathematician. Ramanujan had written to many mathematicians in England, they had not responded. Hardy immediately saw this man is a genius. So he brought Ramanujan over to England. Lot of effort. I'm cutting the story short. It was not easy. Ramanujan's mother would not let him go. Mother did not allow his wife to go with him. So Ramanujan went alone and he was miserable, sometimes homesick, sometimes depressed. But he was working with Hardy and making astounding mathematical discoveries that are keeping mathematicians busy now and for the next 100 years. But he fell ill. He fell ill seriously. And so Hardy sent him back to India because he thought he may die. He came back to India and he knew he was going to die. I have read an article by his wife in Tamil. When Ramanujan's birth centenary was being celebrated in 1986, his wife wrote an article on Ramanujan and her. And in which he writes that he came back to India and he was seriously ill, and he also knew some astrology. Now, I don't want you to waste your time with astrology, but she writes that he predicted the date of his death 1 year in advance. The date, not the month, the date. And he died very close to that. So he told his wife and mother not to worry that it is fated that he will die. Yet he continued doing mathematics of extraordinary kind. And because he was so famous, all his life he had been poor. His father, mother, brother and wife were all dependent on Ramanujan. Because in England he had become famous, he was earning a good salary. And his family was using that money. He came back to India, the British government sanctioned another handsome salary. Now look, I want the young to understand what Ramanujan did. Now he knows he will die in 1 year. He knows that father, mother, brother, wife, all dependent on Ramanujan. His money. Yet, he does not take that money. He tells the government, the British government, use this money for poor and talented students. He gives it away. This is how this great son of India discharged his debts to our nation. This is why this nation remains alive and great. Because these great sons, great daughters, they understand that we must discharge what we owe society. He knew that Indian society had helped him become what he had become. And you know, when he died, his wife lived in great poverty for a long time. Finally, Mrs. Indira Gandhi, someone told her that she is living in great poverty, and then she gave her a good salary. After that, she became comfortable. But what was his contribution? All the great mathematics that he did was one thing. The second contribution, understand this. Ramanujan, when he came on the scene, we were a colony of the British, completely demoralized. We were all thinking the white man is superior, we are useless. That's what they had done to us. And then suddenly here comes this man, not only is he equal to them, better than them. And you know, it inspires a whole generation of Indians. I'll give you just one example. In Chennai, just after Ramanujan's time, there was this student, studying in a college in Chennai. He went on to win the Nobel Prize in Physics. His name was Subramaniam Chandrasekhar. He went away to America and won the Nobel Prize in Physics, but he was a student in Chennai. What does he write in his autobiography? If you can, read the autobiography. He says, when we were students, India was under British rule, we were demoralized, but four names gave us hope and inspired us: Mahatma Gandhi, Ravindranath Tagore, Jawaharlal Nehru, and Srinivas Ramanujan. That was the magic and the inspiration of Ramanujan. That is why I am telling you this story. Each one of you is Ramanujan's child. Each one of you carries the same traditions, the same genes that Ramanujan carried. You are all children of India. Use his example to do good things and to discharge your debt to society. Thank you very much. Jai Hind.
Thank you, sir. A truly thought-provoking lecture for the young minds of the nation and a rare opportunity to hear firsthand from the expert himself. Can we have a standing ovation for Padma Shri awardee, Professor Dinesh Singh? As we are nearing the end of the session, I would like to call upon Dr. C. Porkudi, Professor and Head of Department Mathematics, to deliver the word of thanks.
Good afternoon to all. It's great honor and privilege to propose the vote of thanks on this memorable occasion. Mathematics is the gate and key to science, and without mathematics, there is nothing we can do. So today we had a nice informative talk by eminent mathematician Professor Dinesh Singh on mathematics from industrial civilization to self-taught genius, the man who knew infinity, Srinivasa Ramanujan. Professor gave insight on how our ancestors are familiar with the concepts of mathematics, the geometry, scaling, designing of the bricks and all. Even our mathematicians, how they are familiar with the today's mathematical concepts of trigonometry, calculus, then how they proved the Pythagoras theorem, and the sum of first and natural numbers, sum of the cubes of first and natural numbers and all. On behalf of our PhD College of Technology, I thank our chief guest, Professor Dinesh Singh, Padma Shri awardee, former Vice Chancellor, Delhi University, for having this inspirational talk on mathematics. My sincere thanks to our principal and management for providing us an opportunity to have such an interesting talk on mathematics. A special thanks to Dr. Kaila, Dean Research, and Dr. R. Narajan, Dean Placement, for arranging this event. I thank all heads of institutions, deans, head of the departments, faculty members from our institution and other institutions for their interest towards this event. Finally, I thank all our students for their active participation and making this session a remarkable one. Once again, I thank one and all present here. Thank you.
Thank you, ma'am. The session for the afternoon has ended. We hope you had a good time at the lecture today. The session has come to an end. Have a good day.